Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to the Smart City Podcast. I'm Jim Frazer, Vice President of Smart Cities here at ARC Advisory Group. And today we will be talking about the Smart City Planning Standard P2784. It's an IEEE draft standard of which I chair. So let's get started. P2784 really is about digital transformation of public agencies. It's really intended to be a cookbook or a menu or a recipe for what to do first, second, and third, and what not to do as you're considering building your smart city. So it really is a digital transformation plan that you'll have once you manage the process according to the P2784 guidelines. So let me just start with a quote from the Salesforce co-CEO Keith Block recently at the World Economic Forum. There, he said, there's a lot of discussion about digital transformation, and that when he speaks to other CEOs, they talk about the three pillars of digital transformation. And according to Block, the first pillar is really a technology refresh. He was referring to updating technologies within an organization to maximize efficiency. An example of that would be when a company moves from an on-site technology to hosting applications in the cloud. However, he remarks, just doing a technology refresh is not in and of itself digital transformation. He continues, you have to do all three elements of digital transformation. So the first is the technology refresh. The second is a business model change. So Block explained that this is not limited to any one industry, but applies to all industries. An example he gave was how companies that typically have B2B models are thinking about also moving to direct-to-consumer strategies. Something like this is considered a business model change. Lastly, the third pillar of digital transformation is cultural. So you're introducing new technologies into an organization. You must ask, what's the ethical use of this technology? You have to ask about the impact on the workforce. And is your organization and its people ready to accept the technology? What are the implications of reskilling, which is a big topic in this fourth industrial revolution? This is just the beginning, Block argued. These digital transformations will take some time. Everyone absorbs these technologies at different rates. However, we do see a lot of opportunity to drive great results for our company, Salesforce.com, but even more importantly, for our customers. So the point of Keith Block is that there are three pillars of digital transformation. So as we go through the P2784 draft standard today, let's keep that in mind. So in what things do you really need to think about? Well, first, what are the smart city drivers, barriers, and benefits? Smart city drivers: growing urbanization, growing stress on people in terms of regulatory requirements, tax revenues not keeping up with expenditure, increasing populations, inadequate infrastructure, growing economic competition. Growing environmental challenges, growing expectations, and rapidly improving technology capabilities. What are some barriers? 4 large barriers are, 1, a lack of staff, a lack of information and communication technology domain expertise. Fortunately, there's a robust ecosystem of private partners out there in the world, many of which specialize in public-private partnerships and public infrastructure applications. A second barrier is siloed piecemeal implementations. Cities often tackle challenges in a phased approach due to annual budgeting as well as legacy issues that separate city functions into separate siloed departments with little or very often no interaction whatsoever. As a result, many projects are built to satisfy a single vertical problem in a single vertical department, creating islands of automation that duplicate expenses while making it very difficult or impossible to share data across those boundaries. A third obstacle or barrier is lack of capital and financing. We all know budgets are strained, making infrastructure projects increasingly difficult to deliver. Fortunately, there's a variety of new financial models that are emerging. As-a-service monthly subscription models require little or very often no upfront capital from the city. Instead, the city rents the solution as it goes. And once a predefined payment term ends, the city receives title to the infrastructure. This is very often used, very commonly, in LED street lighting retrofit projects. And one last barrier is lack of citizen engagement. Significant stakeholder outreach and engagement is required. It's not optional. Not enough discussion exists today around all of these smart city issues, and citizens really need to be informed and their needs need to be extracted. Now, the benefits of smart cities, I think we all know very well. Enhanced livability is one, which includes a better quality of life for city residents, access to a comfortable, clean, engaged, healthy, and safe lifestyle. And enhanced livability includes inexpensive energy, convenient transportation options, good schools, fast emergency response rates, clean water and air, low crime, as well as the softer access to diverse entertainment and cultural options. In addition to enhanced livability, enhanced workability is a benefit of a smart city. So that includes accelerated economic development, access to the foundations of prosperity, fundamental infrastructure services that let people compete in the world economy. And what are those? Well, they include broadband connectivity, low-cost, reliable, clean energy, educational opportunities, affordable housing and commercial space, and efficient, cost-effective modes of transportation. Sustainability. One benefit of a smart city is that if it's correctly applied, it will support the three pillars of sustainability, which the first pillar is preserving and enhancing the natural environment. Pillar number 2 is preserving and enhancing the human quality of life. Now, those two pillars of the natural environment and the human quality of life are the ones that all of us generally ascribe to sustainability. However, the third is doing those first two in an economically reasonable approach. That's shorthand for a quick payback. So really, the goal there of a smart city is to be sustainable as well. And some of you may know the Venn diagram with the overlapping three ovals of social, environment, and economic, where at the convergence of all three of those circles, we have the word sustainable. So that's just a brief overview of challenges and benefits of a smart city. Let's talk a little bit about the 5 human factors. Before we even try extracting user needs out of stakeholder communities and applying a systems engineering process, it's very often it's a huge benefit to your project planning if you inform the stakeholders of technologies and applications and market developments that are happening that might impact them. It lends to a more well-rounded conversation and much broader and deeper user need definitions. So the IEEE standard tends to group these into 5 buckets. Social factors is number 1. That includes population growth, urban migration, aging society, mobile working patterns, the changing of household patterns, income inequality, employment, the cohesion of community, and how tight and connected is a community, or is it a group of residents that don't know each other? Informal settlements. In many places, particularly in developing portions of the world, informal settlements are on the rise. Public health issues, certainly very important in this COVID-19 time of ours. Education is a social factor. Individual safety. Tourism. As we know, some very popular tourist areas of the world are suffering from a degrading environment and a degrading perception of value because of simply the amount of tourism and the wear and tear on the infrastructure. The growing global middle class is a social factor. Human well-being, sustainable behaviors, digital lifestyles. Just about everyone has a smartphone today, where they didn't in the relatively recent past. Housing, affordable, clean housing is a social factor. So is the response to infectious diseases and support of entrepreneurship. So that's a quick view of about 20 social factors that really should be thought about when you do build your smart city. Along with social factors, we have economic factors is number 2 in that list. And that includes regional connectivity between adjacent public agencies, let's say, aging of infrastructure. In many parts of the world, the infrastructure is quite old, may not have been built to last as long as it's being asked to perform. Finance, of course, is an economic factor. The circular economy that's gaining traction in the world. The skills shortage, particularly in STEM jobs. An increasing focus on user centricity, that the user, the customer, is to be focused upon. Responsible business, resilience, or better defined as a response to a short-term disruption, whether it be weather or something else. The move towards a digital economy, urban logistics, urban manufacturing, the rising influence of women in the economy, small business, supply chain vulnerability, obviously very important in these days of the coronavirus. The informal economy, self-sufficiency, city marketing and city identity, and of course, economic growth. All of those are economic factors that really should be taken into consideration. Environmental factors is the third group of human factors. And this includes water management, food security. In regards to food, many individuals in many countries, including the U.S., live in a fresh food desert where fresh food is not available in their location. Green infrastructure, waste minimization, air quality, pollution, recycling, biodiversity loss, heat stress, sanitation. All of these are environmental factors that really should be considered as you plan your smart city. After environmental factors, there's of course political factors. How much public space should we have? What kind of building standards? What type of policing should we have? How about the form of urban governance? How much do we subsidize certain public agency applications like transit? What about terrorism? What about system interdependence, both within our agency and intradependence with other adjacent public agencies? Environmental policy. What type of leadership do we have? How transparent is the public agency and the elected officials? How much institutional capacity do they have? What about public opinion? How far do you reach out for stakeholder engagement? How aggressive are public-private partnership efforts? How much privatization is to be permitted and encouraged? As well as global competitiveness, because all cities and public agencies are competing worldwide for labor. Of course, global politics, and in fact, even the election cycle plays a role in your smart city planning. So all of those are very important as you move through your smart city planning process. All those human factors are foundational. And before you get into developing your user needs and defining your stakeholder communities, you probably want to move on from all of those human factors to a real in-depth examination of what is it that your public agency does and what technologies do they use to do it. So within the IEEE P2784 standard, we've embraced the Smart City Council's definition of what is a smart city. And that definition includes a infographic, actually a spreadsheet, that across the top of the spreadsheet has 9 vertical applications that are the most common vertical applications and services provided by a public agency. And this includes the built environment, so that's schools, firehouses, fire and EMS, the municipal building, the built environment is number 1. Then there's energy, because many public agencies do own their own electrical distribution infrastructure and occasionally even the generating infrastructure. So energy is number 2. Telecommunications equipment is number 3. Transportation. Of course, many cities and states and public agencies own a variety of transportation assets. Water and wastewater equipment and processing. Health and human services. Public safety, police, fire, EMS is number 7. The payments and the finance. As we know, cities generate revenue by taxes, by payroll taxes, property taxes, and wage taxes. And lastly is waste management. That's also an industry going through a transition where landfills and burning of waste is no longer looked on as an optimum solution. So those are the 9 vertical applications that you'll need to examine. How many of those do you support and in what way? That's buildings, energy, telecommunications, transportation, water and wastewater, health and human services, public safety, payments and finance, and waste management. So what technologies underlie those 9? Well, instrumentation and controls at the lowest level. Consider that your control devices, switch gear, and pumps. Then, of course, you need connectivity, number 2. Interoperability, so there's a plug and play and you're not forced into a siloed situation. Number 4, security and privacy, including cybersecurity. Number 5 is data management. Number 6 is computing resources. And 7 is the business intelligence derived through use of analytics. So those are your 7 technologies and your 9 vertical applications, which are all very, very important. Now, there's a lot of standards out there, and P2784 is only one. Of course, there's standards there's a range of U.S. Department of Transportation Intelligent Transportation System interoperability standards. There's standards from the Illuminating Engineering Society on roadway lighting levels and the associated controls and edge devices that are associated with them. There's many, many standards. And in one section of the IEEE P2784 standard, there is a reference guide that points you to where you can go to learn more about other standards, planning standards, technology standards, interface standards, for example. So what actually is in the P2784 Smart City Planning and Technology Guide? Well, there's three major sections. How to create a plan for your smart city, an overview of the 9 vertical applications and 7 technologies, and where to go to learn more. So let's focus on section 1, as we've already talked about the 9 vertical applications and 7 technologies. So what's in section 1? Okay. Well, section 1 really is the classical systems engineering process. And simply, it's a process where you define your stakeholder communities exhaustively. You might have many of them. You define them, and then you query them for what are their problems. What would you change today if you were all powerful? What's your biggest problem on your commute to work? What about when you ride your bicycle? What about when your child walks to school? What are your biggest challenges as a business owner? All of those things are important. These stakeholder communities can include elected officials, the city manager, code enforcement, the business community, taxpayers, environmental groups, special tax districts, bicyclists, pedestrians, the school board, parent-teacher associations. You get it. It's very broad. You might have 10 or 20 of these. So once you've defined your stakeholder communities, you go out and you query them. And you expect long-form narrative responses. What would you do if you were the mayor? Or what would you fix today? However, it's important to remember here that not every citizen has the broadest grasp. No one has a 360 all-knowing view of the future or of the present, for that matter. So it's very important to pose your questions and frame them with many of those human factors that we've previously discussed. So those human factors are a bit of a pre-informative pre-work to your questioning and extracting user need narratives out of your stakeholders. So once you have your stakeholder user needs across all of your defined stakeholder communities, the next step is to compare and contrast all of those and see where there is consensus across all your stakeholder communities. You might get some consensus, you might get a lot. You won't get 100%, you won't get 0%. So it's important there to see which ones have consensus, pare down that list to only those that have consensus, and that will complete your step 1 of building a table of consensus-based user needs from all the defined stakeholder communities. So that's step 1. Step 2 is taking each of those user needs and refining those narratives into measurable functional requirements. So that's something with a number, with a legal range, and with engineering units that can ideally become a request for proposal, an RFI, a project specification. That refinement process into a measurable functional requirement is step 2. In step 3, you create a test plan. And think of this as in terms of guardrails on a road. These test plans ensure that every user need will get supported and addressed and satisfied. but that no other requirements will work their way into your effort, so you don't have scope creep. So testing too is very important. I'll go a little bit more detail into systems engineering, that your user needs are collected into that consensus-based list. That is called a concept of operations, more formally. And it really is foundational and can be even reused in other projects. The concept of operations goal is to clearly convey a high-level view of the system to be developed that each stakeholder in each stakeholder community can understand. So it really answers the who, what, when, where, why, and how about the system from the viewpoint of each stakeholder. So it really is arguably the most important part. Now, once you do have that concept of operations, I talked about refining those user needs into measurable functional requirements. A requirement, more formally, is defined by EIA 632 as something that governs what, how well, and under what conditions a project will achieve a given purpose. So there are a variety of requirement types. One is functional. It defines what. A performance requirement defines how well. And a non-functional requirement defines under what conditions. So you can see the flow of how systems engineering works its way through your smart cities project. Systems engineering and your user needs, your test plans, your functional requirements are really meant to address the entire life cycle, from project conception all the way out to project retirement and replacement. That's an important fact to remember. So that's really a quick overview on the essentials of what is in the draft version of IEEE P2784. We quickly talked about what are the smart city drivers, barriers, and benefits. We reviewed the 5 major human factors and quickly went through the 20 factors within each of those. We examined the 9 vertical applications and 7 technologies that are part of smart cities. We mentioned a few other standards. And then we really looked at the IEEE P2784 planning process, which is an outgrowth and is inspired by the US DOT's Intelligent Transportation Systems engineering process. So with that, I thank everyone for listening today, and we hope to see you again soon on another episode of the Smart City Podcast by ARC Advisory Group. Thank you very much for attending today.
Broadcasting from Boston, Massachusetts, the Smart Cities Podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.